Hey ladies and gentlemen, welcome to Unit 7. We are going to do 7.1 today on Pythagorean theorem. So we have a squared plus b squared equals c squared. That should be familiar. The things that we do today should not feel new to you. So let's go ahead and get going into this. We're going to find our answers in simplified radical form, and we're going to do them in decimal form just so that we're prepared for whatever we're asked of us later in this unit or the rest of this year. So let's go ahead and just review that the hypotenuse is the one that's across from our 90-degree angle. So in this example, we're going to be looking for that hypotenuse. So 6 squared plus 15 squared equals c squared. 6 squared gives us 36. 15 squared is 225. So we can go ahead and add those, and that gives us 261 equals c squared. Now to get c by itself, we're going to take the square root on both sides. The square root of 261, first we always ask ourselves, is that a perfect square? And it is not. So then we ask ourselves, is there something I can divide out of 261? Now I always recommend starting with the higher radicals and working our way down so that we make sure we get the highest one. And so see, if we know that 15 squared is 225, that's not dividing evenly into there. 16 squared is 256. That's not going to divide evenly in there. So we go to 14, 196. Nope. 13 is 169. No. And then keep going all the way down. So hopefully you have a list of this somewhere or you have them memorized. And as you work through it, you're going to end up coming all the way down to 9. 9 is our largest perfect square, and 29. So the square root of 9 gives us 3. And then we put our 29 back underneath. And then if we do it as a decimal, so go square root of 261, that gives us 16.2. All right, so simplified radical form is our first form, and then as a decimal is our second form. All right, I want you to go ahead and pause here and try problem 2 all on your own. All right, so hopefully you worked through that and you got your simplified radical to be 13 square root of 2. And then if you typed in the square root of 338, you get 18.4. So both of those were really easy in the sense of x was our hypotenuse, and that made that easy to solve for. Now we're going to go ahead and we're going to do problem 3. And our problem 3, we'll pull that one out. Looks like this. Let's go ahead and get rid of those. Move that off so it's not distracting. All right, so if we look here, our hypotenuse is 11. So we're not solving for our hypotenuse. Oh, come on. We're not solving, ignore it. Whatever, we're not solving for our hypotenuse. We're solving for a leg. So x squared plus 9 squared equals 11 squared. X squared plus 81 equals 121. We're going to subtract over our 81, and we get x squared equals 40. So we take the square root on both sides. 40, we ask ourselves, is that a perfect square root? It is not, but we can pull out a perfect square root of 4. And so the square root of 4 is 2, and the 10 goes back under. And then, so that's our simplified radical. Or if we give it as our decimal form, that is going to be our 6.3. So there's our 2 solutions. All right, then brings us to a word problem. Word problems are not bad, guys. We can do this. Damon is locked out of his house. The only open window is on the 2nd floor, 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some shrubs, what length of ladder does Damon need? All right, so it's 12 feet up and 5 feet away. So we again are solving for our hypotenuse. So 5 squared plus 12 squared equals x squared. 5 squared gives us 25. 12 gives us 144. So we get 169 equals x squared. So we're going to take the square root on both sides. Again, always ask yourself, is that a perfect square root? And it is this time, it's 13. In fact, 5, 12, 13 is a Pythagorean triple. And so you don't need to have these memorized, but it's handy, sure darn is handy if we have them. 3, 4, 5 is our most common one. 5, 12, 13, and then 7, 24, 25. Often we don't really go a lot. There are more Pythagorean triples, but we don't go past that much. And then just keep in mind that the multiples of that are also Pythagorean triples. So 6, 8, 10, 9, 12, 15. Multiples of any of these are going to also be nice Pythagorean triples. So if you see that you have a triangle and one of the sides is 3 and the hypotenuse is 5, and you recognize that that's a 3, 4, 5, you don't really need to do the Pythagorean theorem because you know that the missing side is 4. All right, so find the value of x. So if we look at this, x is our missing side there. We really can ignore this extra triangle there. It's not necessary. We are solving for a side. So once I set it up, I want you to pause it and solve for that missing side, please. All right, when you go ahead and do that, we end up with the square root of 96. That is not a perfect square root, but we can pull out a square root of 16. And so we get 4 square root of 6. Oops, come on, 16 is our perfect square root. If we put that in decimal form, 9.8 is our decimal. All right, so everything we've seen so far has been super familiar. Number 6, we're going to look at this. We are going to solve for x in the same way by solving, doing Pythagorean theorem. I'm just going to make us a little more work space. But it's different in the sense of that it's got multiple variables, it's got a radical. Some of us just maybe don't feel comfortable with that. So my hypotenuse is my x plus 1. So x squared plus the square root of 2 squared equals x plus 1 squared. I always like to put my radicals in a parentheses because if I have like 3 square root of 2, I'm going to put that whole thing in because the square gets distributed to multiple pieces. And then don't forget our hypotenuse, it's a binomial, so we want to put that in parentheses. So when you have this binomial, you're going to either FOIL or box method that. And when you do that, we get x squared plus 2x plus 1. Squaring the square root turns into just the 2. So when we look at this, I have an x squared on both sides. So I'm going to cancel those. So I get 2 equals 2x plus 1. Now this is just a simple two-step equation. So go ahead and solve this two-step equation. We get x equals 1/2. All right, so, oops, sorry. Let's go ahead and, oh yeah, let's move on to this next one then here. It says find the value of x. If we just look there, it's in the picture, but really we just are going to use this one triangle here. And again, we're solving for the hypotenuse. So I'm actually going to skip that problem. If you want to do it, the answer is 15. So let's go ahead and look at this next one here. I want you to pause here and try and set this up for you, and then pop back on. I'll have it set up, and then pause it, and then solve it. Okay. Okay, did you catch here? X is our hypotenuse this time. X minus 4 squared plus 8x, those are our two sides. Or not 8x, x squared, those are our two sides. So tweak it if you need to, and then you can pause it and solve it, and then we will see how we did. All right, so the x squareds end up canceling. What I did here was I combined these like terms right here, and then I subtract them over to the other side because there was nothing there. So then I get negative 8x equals negative 80, so x equals 10. All right, find the perimeter and the area of the figure. Just a reminder, perimeter is the measure all the way around the outside. So we do have all of our information here for perimeter. We're going to take 13 plus 13 plus 10, and that's going to give us our perimeter of 36. Now to do the area formula for a triangle is 1/2 base times height, or base times height divided by 2. Those are equivalent. The thing we're missing here is our height. So I'm going to actually split it and look at only half of this triangle. Now my base is no longer 10 because I'm only looking at half of this. So it's a 5. All right, so does this ring a bell? Do you guys see something here? There's a little pattern in this one. If you don't, do Pythagorean theorem. That's fine. That's fine. But this is a Pythagorean triple, so our height is 12. So now we can take 1/2 times my base of 10 times my height of 12. And you can calculate that our area then is going to be 60. All right, then we have another shape here and says find the perimeter and the area. Here we are missing this slant here, so we are not able to find our perimeter because of so we can't do our perimeter easily, but we can find our area. This, if you look just at the outline of the main shape, this is a trapezoid. So our trapezoid area formula, remember, is the height times base 1 plus base 2 divide by 2. Now, if you don't remember that, you can certainly break this up into find the area of the rectangle, find the area of the triangle, and then add the 2. That's going to give you the same area as it doing the trapezoid formula. So I'm going to use the trapezoid formula, then I only am really doing a little less work. That's why I'm going to do it. So 12 times 15 plus, now this base on the bottom is our 15 plus our 70, or plus our 7. So it gives us 22. And we're going to divide by 2. So I'm going to go ahead and grab my calculator and type that in. And if you did that too, you should get 222 centimeters squared if you want to throw a label on there. All right, so we're going to use our little triangle here to help us find that slant area in this triangle. So 12 and 7, we're going to look for this. So that's my hypotenuse. So 12 squared plus 7 squared equals x squared. This does not end up being a Pythagorean triple. So you're going to want to go ahead. 12 squared is 144. 7 squared is our 49 equals x squared. So when we add those two, we get 193 equals x squared. 193 is not a perfect square root. And so because we are just using it to find the perimeter, I'm comfortable making this just straight up into a decimal and not even having it as the radical. So this is 13.9. Okay, so now I can put that here and I can add 15 plus 12 plus 15 plus 7 plus 13.9 and add all of those up to find our perimeter. So in adding all those up, we should have 62.9 centimeters. All right, we got one more here. It says, according to your company's safety regulations, the distance from the base of the ladder to a wall it leans against should be at least 1/4 the ladder's total length. Okay, you've been given a 20-foot ladder to place against the wall at the job site. If you want to follow the company's safety regulations, what's the maximum distance x up the wall the ladder will reach to the nearest 10th? So it's telling us here, we're going to put it into decimals. So I'm just going to redraw my picture. X, it's a right angle. This is 20. Now this distance on the bottom, they tell us is 1/4 the ladder's total length. So 1/4 the ladder's total length, which was 20. So 1/4 of 20 is 5. So we're going to use 5 and x and 20 to help us find our missing length. And so 20 is our hypotenuse. So we're going to go ahead and plug that in like this. So x squared plus 25 equals 400. If we minus the 25 over, x squared is to 375. So we're going to take the square root. 375 is not a perfect square root, but I can break it apart into 25 and 15. So x equals 5 square root of 15. Oh, and I just finished telling you before that it says decimal. So we really didn't need to do that. That was just really good practice for us. So the square root of 375, 19.4. Oh, there we go, 19.4 feet. There we go. Sorry about that. All right, guys, have a great day.